Welcome to the Deep Dive, where we cut through the noise to get you well-informed fast. Today, we're taking a deep dive into mastering full-stack developer interviews. This is a truly exciting and competitive space within tech.
Absolutely. The demand for versatile full-stack developers is just surging.
Exactly, and these roles, they're incredibly lucrative, but yeah, intensely sought after. So understanding what interviewers really want is absolutely key. Our mission today is basically to give you the shortcut to being fully prepared. We're drawing directly from a really comprehensive guide on how to ace these high-stakes interviews.
And that shortcut is so important because, well, full-stack development is kind of a unique beast, isn't it?
How so?
Well, unlike specialists who might, focus just on the front-end look and feel or maybe the back-end logic, full-stack developers, they bridge that really critical gap. You're connecting the user experience with the whole system architecture underneath.
Right, connecting the dots.
Exactly. And that versatility, it's not just a nice to have. It's why these roles are so valuable, especially in, say, startups or agile teams, where you need someone who gets the big picture. But the flip side is you need broad knowledge. I mean, database design, server configuration, API development, actually building the UI, deployment processes. It's a lot.
Yeah, sounds like a wide range.
It is. And that breadth is what interviewers are testing for. It really demands this mindset of, continuous learning. You have to keep adapting.
Okay, so let's unpack that. For someone looking to really, nail that full stack interview, beyond just knowing how to code, what are the absolute core concepts? The things that if you don't get them, it immediately shows you're maybe not quite ready. Where do they usually start?
Yeah, good question. They absolutely start with core web technologies,
Yeah.
but they're not just looking for definitions you memorized.
Yeah.
They're gauging your real foundational understanding, your grasp of best practices.
Okay, like what specifically?
So take HTML and semantic structure. It's not enough just to get content onto a page. Interviewers want to see you understand why using elements like header, article, footer, nav actually matters.
So it's about meaning, not just looks.
Precisely. It's about accessibility. It's about SEO. It's about creating code that's maintainable, code that explains itself. A lot of developers, even experienced ones, still just throw divs everywhere. And that kind of quietly undermines the whole semantic value of the site. Then you've got CSS and layout management. I mean, everyone knows the CSS box model, right? Content, padding, border, margin. But interviewers want to see you really get how they interact. And crucially, how box sizing, border box, changes the game for responsive design. It's fundamental.
Right, that little property makes a big difference.
Huge difference. And speaking of responsive, mastering Flexbox and Grid, that's not just about making things look pretty on different screens. It's about efficient, predictable layout management. You avoid those fragile, hard-to-maintain CSS hacks from the old days.
Makes sense. What about JavaScript?
Ah, yes. JavaScript fundamentals. The engine of the modern web, really. Beyond just basic syntax, they'll probe your understanding of, like, variable declarations var, let, const, and their scope. Crucial difference. Event handling, too, the whole life cycle of how a user interacts. And, of course, DOM manipulation, how you actually change the page.
And the newer stuff, ES6.
Oh, absolutely expected. You need to be comfortable with modern ES6 Plus features. Things like arrow functions, destructuring, template literals. They're just standard practice now. Interviewers will expect you to use them.
That's a great distinction you made earlier. It's not just what you know, but the why and how you apply it. So beyond the code itself, collaboration is just massive these days, right?
Yeah.
What about version control? Is that foundational or more like an operational skill?
Oh, it's foundational, 100%. Git proficiency is basically non-negotiable, expected from day one.
Okay.
Interviewers need to see you understand practical branching strategies. Things like Git flow or maybe GitHub flow. And crucially, how to resolve merge conflicts without, well, freaking out.
Yeah, nobody likes merge conflicts.
No. But knowing how to handle them gracefully is key. It shows you can work in a team. It's about demonstrating professional, collaborative workflows, using pull requests properly, showing you can integrate your code responsibly, review other people's code thoughtfully. It's not just about typing git commit. It's about maturity.
What does that look like in practice?
Well, things like creating meaningful commit messages, knowing when it makes sense to create a new branch for a feature or a quick hot fix, and understanding how to revert changes that cause problems safely. I mean, I've seen projects literally grind to a halt because developers didn't have basic Git hygiene down.
Wow. Okay, that really paints a picture. So here's where I think it gets really interesting. Once you've got those basics, those building blocks down cold, what are the concepts that truly separate candidates? The things that show a deeper understanding, the things that make an interviewer sit up and think, okay, this person really gets it.
Right. This is where we move into what we're calling intermediate concepts. We're going beyond just the syntax, more into the architecture and how things connect.
Okay, I'm ready.
First up, HTTP protocol and API design. And again, it's not just memorizing GetD versus POST. So many developers, honestly, kind of treat GetD and POST interchangeably sometimes. And that leads to these subtle but really critical bugs.
Like what?
Like maybe refreshing a page accidentally resubmits a form because it was done with a GET request, or a simple data retrieval call, also DGT, unintentionally changes something on the server. That shouldn't happen.
Ah, right, idempotence.
Exactly. Understanding idempotence, whether repeating a request gives the same result without side effects, that's key for building robust, predictable APIs. And for RESTful API design, they'll look for consistent patterns. Using resource-based URLs, using the proper HTTP status codes, it shows you can create interfaces that others can understand and rely on.
Makes sense. What's next?
Then there's asynchronous programming patterns. This is often a real sticking point for JavaScript developers.
Yeah, I've heard that. Callbacks and all that.
Right, callback hell. You absolutely need to be able to explain how promises offer a much cleaner alternative, and then how async awaits syntax builds on promises to make asynchronous code look and read almost like synchronous code. It vastly improves readability, and error handling becomes much more straightforward.
But why does it matter so much for the user?
Great question. Because long-running operations, fetching data, processing something complex, should never freeze the user interface. If your JavaScript code blocks the main thread while waiting for a network request, the whole page becomes unresponsive. Terrible experience. Understanding async patterns lets you avoid that, deliver a smooth, responsive feel.
Got it. Okay, what else is in this intermediate bucket?
Database integration. Huge area. You need to grasp both relational, SQL databases and non-relational or NoSQL databases.
SQL versus NoSQL, the classic debate.
Well, it's less about debate, more about understanding the trade-offs. When do you use which? SQL really shines with data consistency, complex relationships, situations where data integrity is absolutely paramount. NoSQL, on the other hand, offers amazing flexibility, especially for data structures that change a lot, and it generally scales horizontally more easily. Think large, unstructured data sets.
And ORMs, tools like Mongoose or SQLize.
Yeah, you should definitely know about object relational mapping tools. They can simplify database interactions a lot. Makes writing queries easier sometimes, but it's also important to acknowledge their downsides. They can sometimes create what's called leaky abstractions, where you still need to understand the underlying SQL or database principles, and if you're not careful, they can introduce performance overhead.
Good point. Okay, one more in this section.
Yes, authentication and security. Absolutely critical. This means more than just knowing the difference between authentication verifying who a user is and authorization figuring out what that logged-in user is allowed to do.
Authn versus authz.
Right. You should be able to talk about different systems, like session-based authentication versus token-based systems, especially GWTs, JSON Web Tokens. Understand their use cases, their pros and cons. And then the critical security stuff. Input validation is huge, preventing malicious data from getting in. SQL injection prevention, classic vulnerability. Cross-site scripting, or XSS, protection. And ensuring secure communication using HTTPS. Showing you understand this stuff proves you're thinking like a professional, building secure systems, not just slapping code together.
That's a fantastic point about thinking like a professional. Okay, so for those aiming higher, maybe senior roles, or even just folks curious about the cutting edge, what are those advanced topics that really define that next level of full stack expertise? What are interviewers looking for when hiring someone to, say, architect systems or lead development?
Right, this is where we get into the truly advanced topics. This signals someone who understands the bigger picture, the system-level thinking. We often start with system architecture and scalability. Think about microservices architecture.
Microservices. Everyone talks about them.
They do. And it's about breaking down those big monolithic applications into smaller, independent services. Now, it's not just a buzzword. It offers real benefits. You can deploy services independently, use different technologies for different services, improve fault isolation. If one service fails, it doesn't necessarily take down the whole app, but it also brings complexity. You're dealing with distributed systems, network latency, more operational overhead. It's a trade-off.
And containers. Docker, Kubernetes.
Exactly. Containerization with Docker, packaging your app and all its dependencies together for consistency across environments. Huge productivity win. And then container orchestration with Kubernetes, or K8s, for managing and scaling those containers in production. Kubernetes itself can have a pretty steep learning curve, especially when you start managing stateful applications within it.
Definitely sounds advanced. What's next?
Performance optimization strategies. This is massive at a senior level because performance directly impacts user experience, SEO rankings, conversion rates,
Mhm.
basically the business's bottom line. It's not just a nice to have.
Okay, what kind of strategies?
Well, things like code splitting, only loading the JavaScript bundles the user needs right now, making that initial page load much faster. Sophisticated image optimization using modern formats like WebP or AVIF, proper compression, responsive images, various caching strategies, understanding browser caching, using content delivery networks, CDNs, server-side caching, lots of levers to pull there. And database optimization going beyond basic queries, really digging into indexing strategies, analyzing query performance plans. These often yield really significant performance gains.
Right, getting those database queries snappy.
Absolutely.
Mm.
Then testing methodologies become non-negotiable at this level. You'll be expected to understand and likely practice test-driven development, or TDD. That philosophy of writing tests before you write the implementation code. It really changes how you approach development.
It forces you to think about requirements first.
Precisely. And you need to clearly differentiate between different types of tests. Unit tests for individual functions or components in isolation, integration tests to make sure different parts work together correctly, and end-to-end tests, which simulate a full user journey through the application. It's all about building robust, maintainable, and frankly, reliable systems that don't break unexpectedly.
And CI/CD seems crucial for advanced roles.
You can't really be senior without understanding CI/CD pipeline implementation. Continuous integration, or CI, is about automatically integrating code changes from developers into a central repository, running builds and tests frequently. Continuous deployment, or CD, extends that automation further, automatically releasing code changes to production once they pass all the tests. This whole process drastically reduces errors, speeds up delivery cycles, and really enables that culture of rapid iteration that businesses want. Tools like GitHub Actions, GitLab CI, Jenkins are common players here.
Okay, so system architecture, performance testing, CI/CD, anything else?
Yes, finally, framework-specific knowledge goes much deeper. For the React ecosystem, for instance, expect detailed questions on component-based architecture, why JSX works the way it does, a deep understanding of component lifecycle methods, especially with hooks now, state management patterns, Redux, stand, context API, knowing the trade-offs, and critically, how the virtual DOM actually works to optimize rendering performance.
And for the backend, like Node.js?
For Node.js backend development, yeah, understanding its role in a full-stack JavaScript environment is key. Deep knowledge of a framework like Express.js is usually expected, but crucially, a nuanced understanding of the Node.js event loop, how it handles asynchronous operations, and how not to block it. That's a common pitfall even for experienced Node devs. Blocking the event loop kills performance.
And databases again, but deeper.
Exactly. In database management, if it's MongoDB, maybe they'll ask about aggregation pipelines for complex data analysis, advanced indexing strategies beyond the basics, or configuring replica sets for high availability. If it's SQL, expect questions on complex table relationships, deep dives into normalization principles, and when to denormalize for performance. Advanced query optimization techniques, understanding execution plans. It's about mastering the tool.
Wow, okay. That is definitely a lot of depth required for those senior roles. So switching gears slightly, it's clearly not just about knowing all this tech inside and out, is it? What about the human side of interviews, the behavioral stuff, the problem-solving aspects? How do they assess that?
You're absolutely right. Technical skills alone, honestly, they don't guarantee success, especially as you get more senior. It's equally, maybe sometimes more important to demonstrate how you approach problems, how you communicate, how you work within a team.
How do you show that in, say, a coding challenge?
The key is to think aloud. I don't just mean rambling. It should be structured. Start by asking clarifying questions. Make sure you understand the problem fully before you jump into coding. Then, outline your approach, your logic. Then start implementing the solution. And finally, discuss trade-offs. Talk about edge cases you considered, potential improvements, maybe alternative solutions, that whole structured thinking process. That's what they're really evaluating, often more than just the final code.
That makes sense. And for behavioral questions?
Prepare specific examples. Think about challenging projects you worked on, times you collaborated effectively with a team, and, importantly, how you learn from failures or mistakes. The STAR method is really useful here. Situation, task, action, result. Frame your answers that way. It provides structure and ensures you hit the key points.
That thinking aloud strategy. Yeah, I can see how that would be really valuable, but maybe easy to forget in the moment. So, given all this, what are some of the most common pitfalls? The things that candidates should really watch out for, the mistakes that trip up even people who seem technically strong?
Yeah, there are definitely a few recurring ones. One big one is candidates struggling with explaining complex concepts simply. You might have this incredibly deep understanding of, say, microservices architecture, but can you explain the core ideas to a project manager or someone else who isn't deeply technical?
Right, the elevator pitch for a technical idea.
Kind of, yeah. Practice describing technical topics to non-technical audiences. That skill is just invaluable on any team. Second, avoid claiming false expertise. Seriously,
Yeah.
if you've only touched a technology briefly, just be honest about it. Interviewers will probe deeper if you claim mastery, and superficial knowledge gets exposed really quickly. It's much better to say, I'm familiar with the concept, I've done a tutorial or a small project, but I haven't used it extensively in production. Honesty builds trust.
Good advice. Anything else?
Yeah, finally, don't neglect the human side of development. Companies aren't just hiring coding machines anymore, if they ever were. They want engineers who understand user needs, who can align their work with business requirements, who contribute positively to the team dynamics. Being technically brilliant but difficult to work with, that's often a deal breaker.
Incredibly practical advice. Okay, so different interviews have different vibes, right?
Right.
You might have a quick phone screen, then a coding challenge, maybe a system design whiteboard session. How can you best prepare for those specific formats?
That's a smart way to think about it. Tailor your prep. For those initial technical screening calls, really focus on your fundamentals, core concepts, high-level system design ideas. Be ready to explain things concisely and confidently. These are often filters looking for red flags.
Okay.
For coding challenges, yeah, practice on platforms like LeetCode or HackerRank is helpful. But don't just memorize solutions.
Mm.
Focus on understanding the underlying patterns, the data structures, the algorithmic approaches. It's about problem-solving ability, not just recall.
Right, the how, not just the what.
It's exactly. For system design interviews, this is all about your architectural thinking. Practice designing scalable systems. Think about database choices, caching layers, load balancing, identifying potential bottlenecks. Don't feel pressured to design the entire perfect system on the spot. Focus on the critical components and explaining your trade-offs.
And behavioral.
Behavioral interviews, like we said, have those specific examples ready using the STAR method. Think about collaboration, conflict resolution, learning from mistakes, leading initiatives. Concrete examples are much stronger than vague statements.
Makes sense. Okay, one last big area. The tech world just moves at lightning speed. How do you possibly stay current? It feels like there's a new JavaScript framework popping up every single week. How do you keep up without getting completely overwhelmed?
It is a challenge, no doubt. It truly is a continuous process. And yeah, the key to not getting overwhelmed is focus and maybe a bit of strategy. I usually recommend following reputable industry blogs and websites, subscribing to well-curated newsletters, things like JavaScript Weekly, Node Weekly, maybe a good DevOps one, and actively participating in developer communities, whether it's Stack Overflow, Reddit communities, Discord servers, seeing what problems people are solving.
But how do you avoid chasing every shiny new thing?
That's the real secret, I think.
Oh.
Focus on understanding the underlying principles, design patterns, data structures, network protocols, architectural concepts. Those things change much, much slower than specific frameworks. If you have a strong grasp of the fundamentals, picking up a new framework becomes much easier because you understand the problems it's trying to solve.
So principles over frameworks.
In the long run, yes. It's also good to allocate maybe a small amount of time for experimental projects. Build something small with that new framework you're curious about. No pressure, just learning. Even if the project fails, you learn a ton. And definitely consider contributing to open source projects if you can. It's a fantastic way to see how others write code, to get feedback on your own code, practice collaboration, and learn real-world development practices. Plus, it looks great on a resume.
That's really solid advice. Okay, this has been incredibly comprehensive. Let's try and bring it all together now. What are the absolute ultimate preparation tips you can give our listener? The things to really focus on to land that dream full stack job.
Okay, final tips. First, build a strong portfolio and make it diverse. Show both front-end work and back-end work. Have clear documentation. Explain your architectural choices, the challenges you faced, how you solved them. It needs to tell a story about your skills.
More than just a list of links.
Exactly. Second, practice explaining your projects. Aloud. To yourself, to a friend, to a rubber duck, whatever works. Interviewers will ask you to walk through specific parts of your projects, explain technical challenges, and the solutions you implemented. You need to be articulate about your own work.
Makes sense. Practice makes perfect.
Third, research the company. Understand their tech stack if you can find it. Understand their business model, their market. Tailoring your answers and asking informed questions shows genuine interest and that you've done your homework.
Good point.
Fourth, ask thoughtful questions. Remember, interviews are a two-way street. Prepare questions about the specific role, the team dynamics, the company culture, growth opportunities. Good questions show you're engaged and thinking seriously about the fit. And maybe the overarching tip. Remember that interviews test your communication and collaborative problem solving just as much as your raw technical knowledge, sometimes more. Being clear, concise, and a good listener can often outweigh knowing every single framework detail.
That's brilliant. Really practical stuff. And I know from our prep, you've got some rapid fire insights from those frequently asked questions people always have, right? What are some of the most common things people ask when they're trying to navigate this whole interview process?
Absolutely. Let's run through a few common ones. People often ask, how long should I prepare? Generally, I'd say aim for 4 weeks of focused, consistent daily practice. It's more about building habits and reinforcing knowledge than frantic cramming right before.
Okay, consistent effort. Makes sense.
And what's the single most important skill?
Mhm.
If I had to pick one, it's probably a tie between problem-solving ability, learning agility, your ability to pick up new things quickly, and communication. Technologies change, but those skills are timeless.
Right, the meta skills.
Exactly. Should I specialize or learn multiple stacks? My advice is usually start by mastering one full stack really thoroughly. Get good at, say, the MERN stack or maybe LMOP if that's your focus.
Yeah.
Then expand strategically based on job market demand or your interests. Don't try to be a jack of all trades too early. Master one first.
Good advice. What if you don't have professional experience?
Ah, yes. How to demonstrate skills without professional experience. Build comprehensive personal projects. I mean, really comprehensive. User authentication, database integration, a nice responsive UI, actually deploy it somewhere. Aim for projects that solve a real tangible problem, even a small one. And again, contribute to open source. It's basically real-world experience you can get without a formal job.
What about money? Everyone wants to know.
What salary range should I expect? Yeah.
Ah.
It varies wildly, depending on location, your experience level, company size. For entry level, maybe $60,000 to $80,000 in some markets. But for senior roles in major tech hubs, it can easily go well over $150,000, even $200,000 plus. You have to research your specific location and level.
Okay, research is key there. How important is DevOps nowadays?
How important is DevOps knowledge? Increasingly vital. Modern full-stack developers are often expected to understand the deployment side of things. Containerization with Docker, setting up basic CI/CD pipelines, deploying to cloud platforms like AWS, Azure, or GCP. It's becoming part of the full-stack definition, really.
Wow, the role keeps expanding.
It does. And finally, how to handle questions about technologies you don't know. Honesty first. Don't bluff. Say you don't have direct experience, but immediately pivot. Explain how you would approach learning it. Draw parallels to similar tools or concepts you do know. Showing your learning process and your problem-solving approach is often more impressive than pretending you know everything.
Fantastic. What an incredible deep dive into the whole world of full-stack developer interviews. We've really covered a ton of ground from those core web technologies and the crucial intermediate concepts right up to advanced system architecture, and just as importantly, how to present yourself effectively beyond just your coding abilities.
Yeah, and I think the key takeaway really is that true mastery, both in full-stack development itself and in nailing the interview process. It isn't about just memorizing every single framework detail or having canned answers for everything. It's much more about cultivating that deep understanding of the underlying principles. Combine that with the agility to learn and adapt as things inevitably change. And, maybe most crucially, the ability to articulate your thought process clearly, to collaborate effectively. That's what shines through.
So for you, our listener, the challenge isn't just about prepping for one specific interview. It's really about embracing this continuous journey, becoming that well-rounded problem solver who can genuinely bridge the gap between a great user experience and a robust system architecture underneath. What facet of this really broad landscape will you dive into first? What's the next step for you to solidify your own knowledge and get ready for that next big leap?
Keep exploring, keep building, and definitely keep learning.